10 set of questions involving variety of quadratic equations where you are going to learn strategies to solve these equations using the concept of factorizing. I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In this video, we'll master the technique to solve quadratic equations using factorizing. Variety of examples you can see on this particular page, 10 of them. They will give you excellent command on this particular concept. Before that, we also discussed 10 similar questions which are shown here. Now these 10 is like a foundation for what we are going to do. So now let us master the technique using this particular video. You can see the variety. We are involving fractions, quadratic trinomials where the coefficient is a is 1 and quadratic trinomials where a is not 1, right? Like this. And different forms of equations. I hope this journey will help you understand and perform better in your exam. In case you want to learn from me, you can always send an email on the address given. Most of my students are doing extremely well. They're right there on top of their class getting awards and scholarships. Now let's begin with the solutions one by one. So we're going to start with a very simple but interesting example. I'll try to show you two ways of doing it. Since our topic here is factorizing, we have to factor and then solve, correct? So we have x squared minus 1 over 4 equals to 0. Now let me remind you that if you have something like x plus a times x minus a, then what do you get? Well, when you expand this, multiplying with x, distributing with x, you get x squared minus ax. And then we have plus ax minus a squared, and that leads to difference of squares. Do you see that? So this property is very well known as to factor difference of squares, we get product of sum and difference. Do you see that? So difference of squares is equal to product of sum and difference. So I hope this concept is clear, right? So looking into this, x squared minus 1 over 4. 1 over 4, can you identify this as a square of a number? Well, it is. You could write this as x squared minus half square. You see that? As soon as you write like this, you can actually factorize and get your answer. And so it could be written as x plus half. So difference of square is product of sum of x and half and difference, which is x minus half, equals to 0. Do you see that? That is what we mean when we are saying difference of squares is equal to product of sum and difference. Very useful property. Once you understand, these questions can be solved in few seconds, giving you huge advantage over your peers. Now it's time to answer this, right? Each factor equated to 0. So once you do that, what do you get? So if I do x plus half equal to 0, I get x equals to minus half, and x minus half equals to 0 yields x equals to half. So we have a clear answer, right? So we say answer or solution. Solution is the values of x which will prove that left side is equal to right side, or solution for normal quadratic equation is getting zeros. So in this case, the solution is that x is equal to plus or minus half. Absolutely clear, right? So let's continue. Take up the next one, which is similar to what we just did. Looks like, but slightly different. Do you see that? This one, x squared over 9 minus x equals to 0. Is it difference of squares? I don't think so, right? It looks like, but it is not. Okay. So here, what you can do is you can factor x from these, right? So we get x as a common factor, and you get x over 9 minus 1 equals to 0. Do you see the variety? So we are introducing you to concepts one by one, not just providing you with exactly similar questions. That's the difference between my test questions and ones you may say somewhere else. So clearly now we have two factors, and to find the answer, what are we going to do? Equate each factor to 0. Is that clear to you? So if you equate x to 0, you definitely get one answer, and the other one is x over 9 minus 1 equals to 0. So now you have to work on it. So you say x over 9 is equal to 1, and that gives you x equals to 9 cross multiply. So we are again here with two answers. So the answer here is x equals to 0 and x equals to 9. Does it make sense to you, right? So like this, you can actually solve it. You can check your solution by substituting, right? So I will say check solution. Let this be an exercise. As you progress, you need to check and confirm that your results are right to gain confidence. This is very important, okay? So we have two solutions here. X equals to 0 definitely gives you 0 on the left hand side, and 9 gives you 9 minus 9, which is 0. Next question here. So we are now moving from binomials to trinomials, right? So let me write down here. We were working with binomials. Now in this exercise, we have moved to trinomials. Now here the trinomial is of the form ax squared plus bx plus c, where a, the leading coefficient, is actually equal to 1, right? So it's much simpler. So in such cases, the strategy is we are looking for two numbers whose product and sum will help us get the solution. So the product of two numbers, let them be p and q, should be 9 times 1. So I'm just writing there 9. And the sum of the two numbers, these two numbers, should be 6. Now clearly the two numbers are 3 and 3. So when you add them, you get 6, right? And when you multiply, you get 9. So therefore, this expression, x squared plus 6x plus 9 equals to 0, can be written as x plus 3 times x plus 3, right? Equals to 0. Do you see it is a perfect square? Makes sense? So we could also write this as x plus 3 whole square equals to 0. Equating it to 0, we get what? We get x plus 3 equals to 0, and that gives you that x is equal to minus 3. So here you can see we have only one solution. And the solution is x equals to minus 3. So this is a parabola which opens up. So if you want to sketch this parabola, it will be kind of like this. Do you see that? Where the x-intercept is the turning point, which is at minus 3. Make sense? And obviously, this point y-intercept is 9. Does it make sense to you? So this time we have a trinomial which has only one solution, and that happens if you have something which is a perfect square. That is to say, if you have something like x plus y whole square, right? So then the solution of x plus y whole square is that x equals to minus y. Get the idea, right? That's the kind. Let's move on and take the next. So here we have 4x squared minus 4x plus 1. So this is also a trinomial, but with a difference. Here the value of a is not equal to 1, right? So the question is 4x squared. Let me rewrite this. Minus 4x plus 1 equals to 0. So in this case, we'll adopt the same method as we were doing earlier. And we did it with earlier 10 questions, right? Product of two numbers, p times q, will be 4 times 1, right? Which is 4. And the sum of two numbers, p and q, is minus 4. So what could be these two numbers? Well, minus 2 can work for us, right? Minus 2 is minus 4 and their product is 4. So what we do is that we split the number with x, coefficient minus 4 here, into 2, which will be like minus 2x and minus 2x. That gives you minus 4x, right? Retaining the rest of the things as such. Now this splitting of the coefficient of x into 2 helps us to factor. You can now very easily see that you can group them, these two groups, right, to get a common factor. So if I group what is common between the first two, 2x is common, right? And we are left with 2x minus 1. Here you could group and factor minus, right? So when you factor minus, we get 2x minus 1. You get exactly same factor, which is common to both, and that is 2x minus 1. So once you take it common, it becomes a factor. And this is 2x, and that is minus 1, equals to 0. Well, this is also a perfect square. So we get 2x minus 1 whole square equals to 0. And now, what is the answer? Well, we have to equate 2x minus 1 to 0. That means 2x is equal to 1 or x is equal to half. So we get one solution, and that is x is equal to half. So our solution is that clear to you? Now let's try to understand these perfect squares. We know how to graph them. There will be a turning point on the x-axis. Now the formula is very clear. Let's say we have x plus a whole square. So it really means you are multiplying x with a, right? X plus a by itself. So when you multiply, you get here x squared plus ax plus a squared. And when you add them, you get x squared plus 2ax plus a squared. So whenever you observe that the center term is twice these two terms, then it is a perfect square, right? So which is like the center term is, this is 2a whole square, this is 1 square, right? So that is how you can identify a perfect square and get your solution. Correct. So let's now move forward and take the next example. I'd like you to sketch this graph, right? And see how it may look like. So these are the things which really help you to understand the topic better, right? Can you identify the y-intercept? It has to be plus 1, right? And this we know is half. Correct. Let's take up the next example, which is also a trinomial where a is not equal to 1, correct? So now we have this trinomials. Can you tell me the strategy? We're looking for two numbers, p and q. What should be their product? And what should be their sum? Product is minus 2 times 6, which is minus 12. And sum is 1. And two numbers which can satisfy this, of course, are 4 and 3. They have difference of 1. Since we need positive 1, we'll take positive 4 and minus 3. They add up to 1, correct? So, we can write this as 6x squared plus split x into these two terms, which are 4x minus 3x, right? And we have already minus 2 equals to 0. So what we have done here is we have split this x into two terms. Do you see that? That helps us to factor since we are now doing group factoring. So try to understand how we progress towards the solution. The idea is not just to give you a solution. It is there in every book, right? Okay, so what is common between 6x squared and 4x? Well, clearly, 2x is common. Dividing 6 by 2, you get 3. And x squared by x, you get x. That is how you get after factoring. 2x, when divides into 4x, you get just plus 2. Minus is common here, so we'll get 3x plus 2 as the other term. Remember, you will get a common factor, otherwise something wrong has already happened. So take care of that. So we are now left with 3x plus 2, common factor between the two, and 2x minus 1, the other factor. You can equate each one of them to 0 to get your solution. 3x plus 2 equals to 0 gives x equals to minus 2 divided by 3. And if you equate the other factor to 0, what do you get? 2x minus 1 equals to 0. X equals to, take 1 to the other side, divide by 2. So we get x equals to half. Perfect. So that is how you do. See, the factors are of the form ax plus b. Do you see that? So we now know that the factors are of the form ax plus b, right? Well, we are more interested in the solution. Apart from understanding the concepts, solution clearly is where the equation becomes true and is true for two values of x, which are minus 2 over 3 and half. Clear? It is a parabola which will open up. So we can always sketch this parabola, identifying the x-intercepts which are at, let's write down, minus 2 over 3 and half. And where is the y-intercept? Minus 2 is the y-intercept. Do you see how I relate the parameters and then sketch? You get the idea? And this point here, which we are looking at, is minus 2. Do you see that? Y-intercept. That's how you sketch. You can go further and find the vertex, which is on the average value of these two, which we are going to learn in another video. Perfect. So I hope it is absolutely clear. Well, in case you want to learn from me, you can always send an email on the address given. Most of my students are right there on top of the class getting highest marks and awards. Let's move on. Take the next question. So this time again we have a trinomial where the value of a is not 0. So it will take an extra step. We're looking for a product of two numbers p and q as minus 12 times 3, right, which is minus 36. And then we are looking for the sum to be the coefficient of x, which is 10. What could be the two numbers? So in this case, what you realize is that if you look for product of numbers whose product is minus 36 or even 36, so what could be in the numbers, right? So numbers could be 1 and 36, right? 2 and 18, 3 and 12, 4 and 9, correct? 6 and 6. Now none of them will give you 10 as sum. You get the idea, right? So therefore, cannot be factorized. You get the idea. So it is important to remember that all the quadratic equations or trinomials may not be factorized, right? So we are looking for the real roots which have rational values, right? Which could be easily, where we could write this in the form of product of two integers, right? So if we cannot do that, then we cannot factorize. So for such questions, we have to apply quadratic formula. Makes sense, right? So which will be also covered in the next topic, correct? So let's move on. So here is an example, very important to understand that all equations cannot be factorized. Perfect. As I've shown you very clearly. Next example, question 18. So we get 10x squared minus 19 minus 2. So now again, we are looking for a product of two numbers, which is 10 times 2, which is minus 20. And we are looking for sum of the two numbers, which is minus 19. This can be factorized since 20 times 1 will give us the result. Minus 19, negative number is bigger, so we'll use minus 20 and 1. Do you see that? So that helps. So we'll split this 19 into two parts, which are minus 20x plus x, and rewrite the whole expression, which is 10x squared minus 20x plus x minus 2 equals to 0. Now let's group 10x squared minus 10x. 10x is common. We get x minus 2. Here we have plus common and we get x minus 2 equals to 0. And that gives us x minus 2 times 10x plus 1 equals to 0. So equating the first one, which is x minus 2 equals to 0, we get x equals to 2. And the second one, which is 10x plus 1 equals to 0, we get, let me write directly, x is minus 1 divided by 10. Clear? So we have two solutions for this trinomial also. So the solutions are x equals to 2 and x equals to minus 1 over 10. Is that clear to you? Now sometimes the solutions are also written in set builder form. Right? So there we'll write them in curly brackets. We say x belongs to real numbers so that x is equal to 2 or minus 10. So we prefer to write lower numbers first. Right. Both are right though. So that becomes in set builder form. Perfect. So that is how we can provide the answer or solution for this example. The next example here is a binomial, right? So let me rewrite this. We have 18x squared minus 8 equals to 0. Now this is not, 8 is not a perfect square. How will you factorize this? Well, we do see a common factor. So identify the common factor, which in this case is 2. So we can first factor out 2. That gives you 9x squared minus 4 equals to 0. You see that? Now 9x squared and 4 are perfect squares. So identify them as perfect squares. What I mean to say is this is like 3x whole square, right? And this is like 2 square. You get the idea. So now you can use difference of squares, and therefore we could write this as 3x plus 2 times 3x minus 2 equals to 0. So do you see the thought process? So this is the thinking process. Visualize and factor. So you could go direct from here to there. Of course, this step is very critical. Once you factor out 2, then you get a clear idea that this is a difference of square. And now you can find the solution, equating each one of them to 0. So 3x plus 2 equals to 0 means x is equal to minus 2 over 3. and 3x minus 2 equals to 0 gives you x equals to, take 2 that side, divide by 3. Correct? So we have two solutions. Let me write down here the answers. So this could be written as x is equals to plus and minus 2 by 3. Get the idea, right? So this parabola is even function which is symmetric about the y-axis, opening upwards. So it could be drawn like this, right? And clearly we have two roots and the y-intercept is minus 8. So this will be kind of like this. Do you see that? So this point here is minus 8 and these are the two roots, minus 2 by 3 and plus 2 by 3. Make sense? So have a good look at how the parabola will look like for this particular expression on the left side. And the equation is the solution, which are the x-intercepts in this particular case. Right. So that is bringing us to almost the end. We have now 4x squared plus 7 equals to 29x. Now these are different kinds of equations where you need to rearrange and solve. So let's rewrite this. We have 4x squared plus 7. Bring minus 29 on this side. Always write your equations with highest degree first, each term, right? Then minus 29x, then the constant at the end. Is that clear to you? Otherwise, you can sometimes mess up. So now we are looking for product and sum, right? Product and sum of the constant with the leading coefficient, which is 28. And the sum of these two is the coefficient of x, which is minus 29. So now the two numbers are clearly 28 and 1. Since the sum is negative, both should be negative. Is that clear to you? So we are going to split this into 2, which is minus 28x and minus x. And we are going to retain the others as such, which is 4x squared plus 7 equals to 0. Factoring 4x from the first two, we get what? We get x minus 7. And we can factor minus here to get x minus 7 equals to 0. So x minus 7 is a common factor, the other one being 4x minus 1. Now we can equate them to 0. Equating the first factor, which is x minus 7, to 0, we get x equals to 7. And equating the second one, which is 4x minus 1 equals to 0, we get x equals to, take 1 to that side, divide by 4. So we have two solutions, correct? The two solutions are x equals to 7 and x equals to 1 by 4. So these are our answers or solutions. Can you sketch it? Well, we have two x-intercepts parabola opening upwards. So sketch a parabola which just opens upwards, right? And draw your x and y axis. Clearly, the y-intercept is at 7. So somewhere here, let's say this is the y-intercept, which is at 7. The roots are positive, so that is not the right line. Do you see that? So it's a good idea to always draw the x-axis first. You know now roots are at which position? Well, they are at 1 by 4 and 7, right? So we have 1 over 4 and 7. Both are on the right side. So therefore, the y-axis should have been somewhere here. Do you see that? So that point now is plus 7. So it helps. You also understand the strategy of sketching from the given equation and showing the solution on the graph itself, okay? So I hope with this, the concept is absolutely clear. Feel free to contact me on the given address. Here is the last question for you. Treat this as a test question. So you need to rearrange and then solve. Perfect. So pause your video, answer this question. Well, here is the solution. So we have 36x squared plus x, bringing 2 to the left side. We get this equation. Now we are looking for a product of two numbers. What should be the product? Well, the product should be 36 times minus 2, which is 72. And the sum of these two numbers should be just 1. So now, that means the two numbers are very, very close to one another. So these two numbers could be 8 and 9, right? So 8 and 9. Since we have a positive sum, the bigger number is positive, smaller one is negative. Makes sense? So we can rewrite this as 36x squared positive 9x minus 8x minus 2 equals to 0. So that's a very important step where we split x into 9 and minus 8x. So let's continue with the solution grouping the first two where 9x is common. So we get what? We get 4x plus 1. Now here minus 2 is common. We do get the same factor 4x plus 1. That means we are on the right path. Take 4x plus 1 as a common factor. You're left with 9x minus 2 equals to 0. So now equate each one of them to 0 and get your answer. When you write 4x plus 1 equals to 0, take 4x on the left side minus 1 on the right. So x is minus 1 over 4. The other factor being 9x minus 2 equals to 0, taking 2 to the other side makes it positive, and then dividing by 9 gives you the solution. So the solution here is what? The x-intercepts, the real solution is x equals to minus 1 by 4 and 2 by 9. Make sense? So that is how we do this exercise on solving quadratic equations using factorizing. So here we have done all the 10 questions, understanding each and every concept, and at times also visualizing what we are doing really. Providing a solution really means what we learn is actually identifying the x-intercepts. Is that clear to you? And what we say is a real solution, right? So some students working at higher level might also find complex solutions, but these examples related to real roots. Perfect. So with that, we come to an end of this particular video. Feel free to write your comments and share your views. If you like and subscribe to my videos, that'd be great. Thanks for your time and all the best. Amita ji, Amma.